Let's start out with looking at equations that will have no solution. So here's our first example. We're going to slide this one down and look at it later. Okay, in this example, our equation is x minus 1 equals x plus 1. This is an example of an equation that will have no solution. So let's go ahead and try solving it so you can see what it looks like when it has no solution. Okay, so we have x minus 1 and x plus 1. It looks simplified, so now I need to get all of my x's on one side of the equal sign, and I need all my constants on the other side of the equal sign. So if I want my x's on this side, that means this x is out of place. It needs to go away. So I need to combine it with its zero pair. The zero pair would be a negative x. So whatever you do on one side, you have to do on both sides. Keep things balanced and happy. Okay, let's do this subtracting x. So x minus x, that's 0. 1x minus 1x, 0. So we still have a minus 1 or negative 1 on this side. And then on this side we have x minus x. Again, that's 0. And then I still have a 1. Okay, this is looking weird already. I have negative 1 equals 1. Think about that for a second. Does negative 1 equal 1? No, it doesn't. That's ridiculous. Negative 1 does not equal 1. So when I end up with an answer like this as I'm solving, that tells me that this equation has no solution. There's no possible number that I can plug in for x that will make this equation true, because it's not going to end up being true. So when we look at the equation, we don't even have to solve it completely to understand that it's going to have no solutions. So let's just look at it and think about what it's telling us. It's saying if we take a number and we subtract 1, that's the same as taking that same number and adding 1. Can you think of any number that we can subtract 1 from and add 1 to and end up with the same result? No, that's impossible. That is impossible. So think about that when you're looking at equations. Look to see, are we taking a variable and adding and subtracting different things from it? So we have the same variable, but we're adding and subtracting different things from it. Here's one more example. In this one we have 3x equals 3x minus 4. Let's go ahead and try to solve it and see what it looks like as we try to solve. Let's move all of the x's again on this side and all of the constants on this side. So that means this 3x is out of place. So we need to combine it with its zero pair, which is a negative 3x. And as we do that, we get 3x minus 3x. That's 0. So let's leave a 0 on this side. And then we have 3x minus 3x is 0. And we're left with a negative 4. So once again, we get an answer that doesn't make any sense. 0 does not equal negative 4. So this right here tells me that this equation will have no solution. There's no number that I can plug in for x that will make it true. Once again, we don't even need to solve it completely to know. We can just look at it and determine how many solutions it will have. So think about it. We have 3 x's, and we're saying that that's equal to 3 x's minus 4. So that doesn't really make sense. Notice we have the same variable. We have 3x on both sides, but we're subtracting different things from it. On this side, we're not subtracting anything from it. On this side, we're subtracting 4 from it. And it's impossible to end up with the same result on both sides if we add or subtract different things from the same variable. So that's your examples of equations that will have no solutions. Your next video will show you examples of equations that will have infinitely many solutions.